Welcome to Ferris University episode number 3. Today I'd like to go into a deep dive on our first AI agents, and I want to explain to you use cases of how civil engineers are using this agents to improve their accuracy, increase their bandwidth, and overall just improve the quality of their product. So if you're new to AI and you're new to AI agents, what an AI agent is a system that autonomously goes ahead, produces checks, runs specific workflows, does specific tasks and goals that the user is going to be specifying in these situations here today. What this allows the engineer to do is to scale your judgment. So there's a conversation going on, is AI going to replace engineers? And currently, how I see it is it's not going to replace the engineer. The engineer is still going to be needed, but the engineer now is going to have a tool of leverage. You're going to be able to take the decisions that you make, the calls that you make, the reasoning as to why you make them, and apply them now with agents over large swaths of your project, throughout different types of workflows, different types of projects that you're working on. And I think this is going to be incredibly valuable and useful to civil engineers who are just so inundated with decision making, workloads, time constraints, things that I was dealing with when I was a civil engineer working full time on design. So here is Ferris, and within Ferris, we have our launch AI agents window. And the first agent that I want to speak to you guys about today is the DeepQuery agent. And many people are familiar with a ChatGPT or a Perplexity, and for this, the interface is very similar, but what we're doing on the back end is very different, and it's why we created this tool. So it is a chat-based system, meaning you could talk to it as you would any other chat-based AI interface. And why this is important is because there are times where you need to have a conversation or have a question or you want to semantically search something, and AI is great for that. The reason why we decided to create DeepQuery here was the limitations that exist in the current commercially available softwares, particularly when it comes to the context window. So what a context window is the number of tokens that a model can perceive and process at one time. For GPT, Perplexity, these commercially available softwares, that context window is about 128,000 tokens, which equates to about 100,000 words. Now, as a civil engineer, we deal with millions of words, millions of tokens, whether it's our drawings, our design guides, our calculations. And when you start to upload these things into a GPT, you realize you get a lot of hallucinations, you get a lot of errors, and the information we're not getting is accurate. I had this experience firsthand in 2020, 2021. I thought that GPT was going to be my design partner. It was not. It hallucinates, it lies. It's not for civil engineering purposes. That's why we created DeepQuery here at Ferris, because that tool of being able to semantically search all these documents and speak to these documents and infuse a level of intelligence within these documents is very important, but we need to be able to do that accurately. And here at Ferris, we've been able to increase our context window size from about 128,000 tokens to millions of tokens. We've been using it on document sets as large as 5,000 pages, as opposed to the 300 pages that you can kind of get through with a GPT. So a few things about this tool and how are we able to do this. The biggest hurdle that we've overcome here is the vectorization and data extraction strategies that we use in order to embed the information you provide to Ferris onto a language model. For me, I like to analogize a language model to a map. It's a map of knowledge. And if you were to look at a map like a GPT, you have, let's say, a 10 by 10 square city block. What we're doing with Ferris is we're increasing that size of the map, and we're taking your information, we're putting it at specific addresses. And when you go ahead and ask it a question and semantically search that information, what it's doing is it's giving you directions to and from and bringing you that information within that language map that we've created here. Another area of importance that I always like to highlight is the types of data extraction that we're using here with the DeepQuery agent. So you need to upload a PDF for the DeepQuery agent to work. We're not compatible right now with any type of CAD or Word documentation. It's strictly PDFs, and then for some agents we allow Excel compatibility, but we'll go through that in a later episode. So right now for our data extraction techniques, we use two different types. One is a metadata extraction. So if you were to generate an AutoCAD file and print it to a PDF, or generate a PDF from Word or Bluebeam, those documents have metadata behind them, and we are able to extract this metadata and use that as part of our embedment into the language models. When that happens, we get very good structured data, which helps us retrieve a lot of information and then spit back out very accurate answers to these semantic queries. The second type of data extraction that we use is an image-based extraction. And this is really valuable when reading through different types of drawings, reading charts, things where the metadata in the background is very hard to structure, or there are cases where there is no metadata in the background of the PDF. If you work in an older building market, like we have clients that work in New York City, where a lot of the drawings are scanned PDFs, there's no metadata there. And typically, how engineers are going to get through these drawings is just going to click through each page and try to read them manually. With Ferris, you're able to now semantically search these documents. Anything that's scanned, if you could read it, Ferris could read it, and you're now able to search for it, look it up, and work with it, as opposed to having to work against it. So users find that very powerful. They seem to like that feature very much. So here, let's take a look at how we're going to be using DeepQuery. It looks like a basic chatbot interface, which I think is relatively native for people and for them to understand. You ask it a question, it provides to you an answer, like, "Hello, Ferris." And then it'll take a minute. Let's see what it says. "Hi there. How can I assist?" See? So it's looking for you to ask it questions. Now, there's a conversation of what different types of codes, which types of documents are pre-trained on the language model. And in my experience, everything that is publicly available information is available on the language model. So if it's not behind a paywall, you're able to access it through DeepQuery, through Ferris. Reservations on that is if it is a piece of trademarked property, like a design guide or a specific calculation or drawing, something that's not available to the public, that is not trained on the language model, and the user needs to provide that in the form of a PDF in order to go ahead and interact with that document and fuse a layer of intelligence into that document. So when we're looking here at what documents are in our library currently, there's a toggle button here where you could select which types of projects you want to be working in or global libraries you want to work in. Here we're going to select the global library, and we're going to take a look at the different types of documents we have here. So we've got a typical detail sheet. Oftentimes, engineers will have a catalog of details, and they'll be looking for a specific detail, and it might be tricky to get to. They might not know if it's even there, or you think you have a detail in a specific project set, and you want to ask Ferris, "Hey, do we have this detail here? Where could I find it? Can I use this on another project?" Instead of having to go ahead and redraft the same detail, come up with something from scratch. Here we're utilizing a lot of the data that's already been generated by your company, by you as the engineer, and we're just putting it to you at your fingertips. All you have to do is ask the question, and Ferris will retrieve that information for you. So let's say, uh, so I'm looking for a typical CMU wall to foundation detail here. And this should live somewhere within our typical detail sheet, but it's a very large document. It's like 54 pages. So I'm just going to ask Ferris to go and find it for me. Um, Depending on the size of the documentation, it might take a minute or two to find, but it will get you there. Sometimes you have to be a little bit patient. If you start getting into the thousands of pages, it might take a minute to pull it for you, but it's better than having to Control F a document, what typically engineers do, or I know we all love our tabbed books. These are also very fun to sit around and kind of flip through pages looking for the correct answer. But now you could ask it questions the same way that you would Google something. And any code that you have in a PDF uploaded to Ferris, you're able to do this with. So when we're looking for the CMU wall, the foundation detail, it's telling us that it's located on page 8 of our typical detail sheet. And we believe here at Ferris that earning your trust is one of the biggest things that we have to do. You need to trust Ferris. You need to trust that what it's telling you is accurate. How do we do that? One way that we're trying to do that is providing a link or a source where we pulled the response from. So that way, when you're reading the response, you don't have to ask yourself, hey, is this correct? Is this not correct? You can click on the link, and it's going to pull up side by side the PDF and where it received this information from. And then you're allowed as the user to go in, and you can see right here, here's our masonry wall to footing detail. And you can go and investigate more. So something else that's very important is how we prompt Ferris to retrieve our information. So what you're telling it, how you're telling it. I'm going to be putting out more content and explaining to you the nuances of prompting, but like the old adage goes, garbage in, garbage out. So the more detailed, the more direct you are with your prompts, the better quality of information you're going to get back out from Ferris when it gets to you. So something to keep in mind. You can kind of chat with it casually, how I'm chatting with it here, but it's not the best way to interact with it. You can give a very long paragraph explanations of what you want it to do, what you want it to look for, and in those cases, we have the highest rates of accuracy and success. So the other day I was trying to go ahead and design column splice, and I was looking for where in the AISC manual it spec'd out column splice specifications, guidance, things of that nature, just to brush up on to make sure that what I was doing was accurate, to code correct. So I put in this question: hey, I'm designing this column splice. Where in the AISC manual can I go ahead and find this? It gives me a few different places to go look. It's telling me on page 1405 it provides general guidance. So we could hop into there, and if you wanted to read some general guidance, you can go about it that way. Then there are different types. So if we have different design requirements, we can go to 1408, and we could take a look at the splice information that's provided here. And then on 1419 as well, you can go and take a look at the tables for typical column splices, different types of plates they'll recommend, different type of weld sizes they'll recommend, to really get to the information that you're looking for, again, as quickly as possible and as accurately as possible. We want to get you the information that you need to design, to put drawings together, to answer RFIs as instantaneously as possible. We should not be wasting time control Fing our way through documents, flipping through pages of design codes. I really think it's important for us to increase our bandwidth as civil engineers, that we start to adapt some of these tools, some of these technologies into our daily workflows. So another real life example of how I've used Ferris professionally was the other day I was working on a project, and a contractor calls me about a separate project, asking me a question about a specific detail. So what I did was I went over to Ferris, I changed in the DeepQuery agent the project that I was working on. So when you jump in within a project, you're able to semantically search your project files as well as those global documents that we were working with before. So I quickly went ahead and I asked it a question about the detail that we were discussing, just so I could pull it up. I wasn't wasting any time jumping to that project PDF, trying to figure out what the detail was. I had it all right here at my fingertips, and I was able to go ahead and speak to the problem at hand very accurately, very quickly. So I was able to pull up the spreader beam detail, and there was a question on the beam size and as well as the welding connection that happened. So again, very valuable, very useful in the sense that when you need to switch frame of reference to a different project, it's not going to take you minutes to find that document, upload that document, and then work in it. You could actually have all that here on Ferris, and all you have to do is semantically search that information to get to where you need to be. So where Ferris could also help out with your design is if you're using any sort of like catalogs to spec out specific products, read certain tables and output specific design information to you. What you can go ahead and do is I've got a Simpson catalog here. I'm looking for roof truss tie downs to CMU walls, and I'm looking for a specific uh, uplift, connection, force constraint. So what I'm going to say is, hey, I need tie downs that withstand 1,100 pounds of uplift force. What types of attachments are going to work here? And here it's going to spit out to you a few different options depending on your truss configuration and the ply size and that bottom chord. And the best part is it'll pull up the catalog for you in the location that you need. So now you can run through this yourself and you could start looking for specific types of tie downs that you might be using on your project. Again, this works really well with like the Volcraft's roof decking catalog or the joist design catalogs. If you put in a bunch of variables that are your project constraints and you ask it for a specific member or assembly, it'll be able to provide that to you. So you don't have to go through and try to read through all the tables, read through all the charts. It'll be able to populate to you that connection tie down. And the last thing that I would like to talk about here today is the process in which we charge for these queries and charge for these uploads. So if we go back to the home page, next to all your documents, when you upload them, there's going to be a column that says what the document status is. Is it a smart document? Is it not? What that means is when you originally upload a document to Ferris using the upload feature, it's not ingested and not embedded into a language model. In order to do that, you need to select the Make It Smart button. And what this is going to do is put this into a language model, making it smart so that you can query against it, you can talk to it, you're adding that level of intelligence to the document. This is this is what we charge for here at Ferris. It's 5 credits per page for the $60 a month subscription. You're going to get 25,000 credits, so you get about 5,000 pages worth of uploads. And this is how we're charging for that DeepQuery agent. You are able to query as many times as you want. We do not charge for the queries. Those are all free. But to upload the documents is where you're going to start to incur cost. For some of our other agents, there are costs to run those. But for the DeepQuery agent itself, all you need to do is ingest the PDF, make it smart, and then you're able to go ahead and query it as many times as you want. So this is our DeepQuery agent. I think there's a lot of value here for civil engineers. There are many more use cases that I would love to show to you in my LinkedIn videos and more YouTube videos, and we'll be doing that as well. I wanted to keep this relatively short just so you get the understanding and the idea of what DeepQuery can do and the power and capabilities that it has. So thank you again for tuning in to Ferris University episode number 3, and I hope that you watch number 4, 5, 6, and as many agents that we make and how many topics we cover. I hope you find a lot of value in these videos, and if you're working in Ferris already, thank you very much. I really appreciate it, and if you're new to the platform, I hope that this is something that's intriguing to you, that you see the value in it as well. And if you ever want to talk about it, please reach out to me personally. You can do that on our website at askferris.io. You can reach us on LinkedIn as well. So yeah, I look forward to talking to you, growing, and showing you what we have to build here in the future. Thank you.